Dear students, Assalamu alaikum and welcome back to Plant Physiology course with the discussion of imbibation. Our previous video was an introduction to the process of imbibation, and we saw an example and that of wood. That wood is a very good adsorbent, and when placed in water it imbibes water due to difference in water potential. As we have seen while discussing osmosis, that if a solution is confined in a semi-permeable membrane and then osmosis is allowed to take place, then pressure builds up within that solution within the membrane. Similarly, an adsorbent, if it is confined, then tremendous pressure can develop if an adsorbent is confined and then it is allowed to imbibe. For example, if there is a crack in the rock, suppose this is a rock, and a piece of wood, a stick of wood is driven into the rock, and then this is wood, and then it is soaked. So this dry wood, when soaked with water, and its other end, this one is already driven into a crack in the rock. This is a rock. So what happens, that tremendous amount of pressure develops, because when this piece of wood or adsorbent imbibes water, absorbs water, it swells up. So what happens, that it can even crack the rock. So much pressure develops that the rock can be cracked, and in fact this method has been used in the past to crack rocks. Now the conditions which are necessary for the process of imbibation to take place. Conditions necessary for imbibation. So as you can guess the possible conditions, the first one is water potential, and as we have already seen, unless there is a water potential gradient, there will be no imbibation at all. A psi W or water potential gradient, it must exist between, and obviously there are two things, the surface of the adsorbent and the substance being imbibed, and in this case and in most cases it will be water. So a water potential gradient is necessary for imbibation to take place between the surface of the adsorbent and the substance which is being imbibed. If there is no water potential gradient, there will be no imbibation. So this was the first condition. The second condition is the affinity, and again the affinity is between these two, the adsorbent or the imbibant and the substance being imbibed. If there is no affinity between these two things, between these two substances, then obviously it's very difficult for the imbibation to take place. So affinity again between adsorbent and the substance which is being imbibed. So this is necessary. As far as the first condition goes, that is the water potential gradient, so it must be noted that a very steep water potential gradient exists in dry plant material. For example, in dry seeds, as low water potential as minus 900 bars has been reported in dry seeds. So this is an extremely negative water potential, and obviously when such seeds are placed in pure water, a steep water potential gradient is established and water moves very rapidly into the seeds. So for example, this is again a container and we have placed these dry seeds in the water, and the water potential, as we have just seen, it's very negative, about minus 900 bars, and these seeds absorb water or imbibe water very rapidly. And as the imbibition proceeds, that is the adsorbent, which in this case are seeds, the water potential becomes less and less negative because of the imbibition of the water. And finally, a point is reached when an equilibrium is established, and that is movement of water in and out of the seed becomes equal. So it is almost the same scenario, the same situation which we have already encountered or observed as far as the osmosis or diffusion is concerned, that all of these processes, they usually proceed towards equilibrium. So in this case, finally an equilibrium is reached. This was something about the first condition, that is water potential, as far as the process of imbibition is concerned. And the next one was the affinity. Now an imbibant may not adsorb or imbibe every substance or all kind of substances. So for example, rubber, if placed in water, there will be no imbibation. However, if this rubber is placed in ether, so what will happen? That imbibation will take place, that is the rubber will imbibe ether and rubber will swell up. It swells up because of the imbibation of ether. On the other hand, if seeds are placed in ether, the same seeds that we have just seen, when placed in water, they imbibed water. But if the seeds are placed in ether, there will be no imbibation. So these two conditions are very important as far as the process of imbibation is concerned. That is, imbibation to take place, water potential gradient and affinity between the imbibant and the substance being imbibed must exist. And why ether does not imbibe water, or why seeds does not imbibe ether, and this is related to the attractive forces. Attractive forces between these two substances, that is imbibant and the substance being imbibed. These attractive forces play a very important role in the process of imbibation. Since we are mostly interested in the plant material and imbibation in plant material, so it must be noted that plant material, whether it's root imbibing water or it's a seed and whatever it is, plant material, it contains a lot of colloidal material. We haven't yet discussed colloids, what are colloids, but anyway, hopefully you might know something about it, but more about colloids later in the course. And especially the colloidal material that is hydrophilic. So in plant cell wall and inside the cell there are proteins that are highly hydrophilic. Hydrophilic means they have very strong affinity for water. And we have been referring to the substance which imbibes water as adsorbent. This is an adsorption phenomenon. And adsorption is a surface phenomenon. The greater the surface available, greater will be the adsorption. And colloidal material has the property that it provides a great deal of surface for the adsorption to take place. The plant cell walls especially contain cellulose and other carbohydrates to which water is strongly attracted, and this helps in the imbibation of water, and therefore extremely negative water potential gradient exists between the dry seeds and the substance which is being imbibed, and which in most cases is water. So in this video we discussed something about the conditions necessary for imbibation. More about imbibation in the next video. Thanks for watching and see you in the next video.